Dear friends, please enjoy the second part of the video. In this, I will give my presentation to power plant water pre-treatment and water treatment. There are 4 steps used in water pre-treatment. Water pre-treatment is the first step in the purifying water. All power plants all power plant water is purified using pre-treatment. The pre-treatment depends on the quality of the water source and how the water will be. And the 4 steps are: number 1 is screening, number 2 is chlorination, and number 3 is softening, and number 4 is filtration. What is screening? It is incoming surface water is screened to remove large debris. Removing branches, fish, plants and other large debris is the first step of water treatment. Since groundwater does not have such debris, it is usually not screened. Water screens must be cleaned periodically to prevent clogging. Mechanical scrapers are used for cleaning the screens. Then what is chlorination? Chlorination is generally the first chemical added to power plant water. This is done with liquid or gaseous chlorine. Once added to incoming water, chlorine forms hypochlorous acid and hydrochloric acid. These acids kills the existed algae, slime, bacteria and other microorganisms in water. The amount of chlorine depends on the incoming water. What is the softening? The water softening removes calcium and magnesium ions in water called clarification. The 3 steps of water clarification are coagulation, flocculation and sedimentation. What is this coagulation? After chlorination, incoming water is coagulated. The process involves addition of coagulants which neutralizes colloidal surface charges. This is the process used before water treatment to improve effectiveness of water treatment. The most common used coagulants are compounds of aluminum and iron. These compounds dissolves and converts the colloids to form positive charges. Water softening is more effective after coagulation. Then second is your flocculation. Following coagulation, softening chemicals, usually lime compound, is added to the neutral water and stirred slowly, called as flocculation. Lime helps in forming flocculants. The flocculants mean this is calcium and magnesium ions form in larger particles. The heavier and larger particles settle in bottom due to heavier. And third one is your sedimentation. This is the final step of water softening. The formed flakes slowly stirred in sedimentation tanks. The heavier particle settles at the bottom of the tank in the form of sludge and conveniently removed by the draining. What is the filtration? Filtration is the final step of water pre-treatment. After softening, the water is passed through a filter. Water filter removes any small flakes and other small particles that remains. 2 common filter types are there. They are gravity and pressure filters. In gravity filters, don't pump water through a filter. That means gravity filter don't pump water through filters. The force of gravity causes water to flow downwards through the filter. In pressure filters, use one pump to filter water. This pump forces the water through the filter. The filter water moves using pressure. Therefore, its flow rate through the filter is more easily controlled. Except of pump, gravity and pressure filters are similar. In this filters, there is a filter media is there. The filter media traps the impurities in water. A filter media has 3 sand filters are there. Each layer contains particles, usually sand of similar sizes. The filter top layer has the largest sand particle. The smallest sand particles are the bottom of the layer. And there is a second is your support bed. Support bed is there. Thus the 3 sand layers are on a gravel support bed. The gravel support bed prevents the small sand particles from seeping downward and separate the bottom layer from the under drain system. And apart from this, the drainage and under drain system also provided. The under drain system collects the filter water periodically. The sand filter becomes clogged with flukes and other impurities. Backwashing cleans the sand filter of traps impurities. The backwash system reverses the direction of the filter usual water flow, means water enters the under drain and flows up through the filter. Backwash loosens the trap impurities and carries them to the filter top. The impure backwash water is then removed from the system. Backwash must be periodically carried over to improve the filter efficiency. There are three methods to prepare water for use as working fluid and closed cooling water system. The first method is reverse osmosis. Process of using pressurizing to filter water forced through screening membrane. In general, osmosis is water flows through membrane from dilute solution to the concentrated solution. Reverse osmosis uses pressure to change the direction of the natural osmosis. The key benefit of reverse osmosis is reducing water impurities before the demineralization. Then the second method is demineralization or deionization. Removes minerals, salts and other ions from raw pre-treated water. This process is very effective. Demineralization removes even a tiny amount of impurities by a process called ion exchange. It involves interchangeability of ions. Water has many free ions such as iron, sodium, chlorides and sulfates. These ions can cause serious equipment problems. Ion exchange removes the undesirable ions from water and substitute less harmful ones. Ion exchange reaction are done in large tanks called demineralizers. These demineralizers, also called ion exchange columns, the basic type of demineralizers are cation demineralizer and anion demineralizers. In cation demineralizers, removes positively charged ions such as iron and magnesium and manganese, and in anion demineralizers removes negatively charged ions such as chlorides and sulfates. Since raw water contains both cation and anions, it is treated in both demineralizers. Cation anion demineralizers are filled with millions of solid beads. These tiny beads are called resins. The demineralizers resins exchange ion with water. The resin in the cation exchanger has free hydrogen ions. The anion exchanger contains free hydroxyl ions. The water exchanges its positive and negative impurities for hydrogen and hydroxyl ions. This process is the key to ion exchange. Pre-treated water first enters the cation exchanger. The incoming water contains positively charged impurities and negatively charged impurities. The cation exchanger replaces positively charged impurities with hydrogen ions. The positively charged impurities remains in the cation exchanger, clinging to the negatively charged resins. The treated water then goes to the anion exchanger, where negatively charged impurities replaces with hydroxyl ions. The negatively charged impurities remains in the anion exchanger and clinging to the positively charged resin. After this demineralization, the outgoing water becomes pure. Water impurities collected in the exchanger resins and pure water is used as a makeup for the steam and water cycle. Eventually, both ion exchanger columns becomes ineffective after some time. The resin no longer contains free hydrogen ions and free hydroxyl ions. Both demineralizers filled with water impurities. Resins that do not exchange ions effectively are referred to as exhausted and must be regenerated. Regeneration replaces exchanged H plus and OH, that is hydrogen and hydroxyl ion in demineralizers. Regeneration also removes water impurities picked up by the resin, rinsing the cation exchanger with dilute sulfuric acid. Regeneration and rinsing the anion exchanger with caustic soda and regenerate it. After regeneration, exchanger contains H plus ions and OH ions as usual. Then the third method is removal of silica. Removing silica from boiler feed water and makeup water is mandatory. Even traces of silica in feed water causes turbine scaling. In general, turbine scaling can be avoided when silica content in feed water is less than 0.07 ppm. Demineralization is the common method of removing silica in feed water. Boiler feed water pressure and pH affects the silica content of stream. The relationship is concentration of silica content in the steam increases when boiler water pressure is increases, and concentration of silica content increases in steam when boiler water pH decreases. Then we will discuss about water treatment. Let us discuss how to minimize fouling, scale and corrosion in the condenser cooling water, and number 2 closed cooling system, and number 3 is working fluid system. Condenser cooling water does not come from the storage tank of pre-treated water. The amount of water required is more than a power plant can pre-treat economically. Condenser cooling water system is generally open circulation system, due to which evaporation rate is more, due to which requires makeup is more. For this reason, condenser cooling water takes directly from raw water source. It is stored in a basin and chemically treated to avoid any damage to system. The water is pumped through condenser and cooling tower and back to basin. The makeup water pump from raw water source. Number 1 is your fouling control. How to control the fouling? Silt and other small debris in the water can cause fouling. To prevent fouling, chemicals such as coagulants, this is your aluminum and lime compounds, add to the basin. These forces to sink the colloids and silt in suspension conditions. Microorganism also causes fouling. Usually chlorine is added to kill the microorganism that causes the biological foulings. And number 2 is scale control. How to control the scale? Scale is not of as much concern as in the boiler, but it can cause heat transfer and flow problem over time. To control the scale, chemical inhibitors are added to the basin. These inhibitors block scale from forming. Then corrosion control. Corrosion, oxygen, chemicals and cell take place. Because the system is open, corrosion is accelerated. The air not only consists of oxygen but also contains from plants stack which aid the reaction. 2 methods to control corrosion in the condenser cooling water system are, number 1 is chemical inhibitor, and number 2 is sacrificial anode. What is this corrosion control? What is this chemical inhibitor? Anodic and cathodic inhibitors added to the basin. They form tough oxide films over the metals in the system. Corrosion cannot get through the layer of the protection. And the second one is your sacrificial anode. Large bricks of metals, usually zinc, are bolted